Assalamu alaikum, dear students. Okay, so we are done with introductory part of photosynthesis, that is general overview of photosynthesis, pigments, absorption, action spectrum. So today we are going to talk about the first phase of photosynthesis, that is light reaction. I already told you that this photosynthesis it is completed in two phases. First phase is known as light reaction, and the second phase is known as light independent reaction, or it is erroneously also called as dark reaction. So remember that this name dark reaction, it is a misnomer. That means it has been given mistakenly, because light reaction, if we say light reaction, it means that this light reaction it takes place in presence of light. So that means dark reaction takes place in absence of light, or that means dark reaction takes place in dark only, but that is not the case. Dark reaction takes place during day, that means during day it is light. So it is not like that. It is not like that dark reaction takes place only in night, it takes place only in dark. No, dark reaction actually takes place during the day. That is why it is mistakenly known as dark reaction. The actual name, that exact name for dark reaction is light independent reaction. That means light is not necessary for dark reaction. Light is not necessary for this second phase of photosynthesis. For the first phase, that is the light reaction, there's light reaction, light is necessary, light is important, light is compulsory over here. But in case of dark reaction, light is not necessary. If there is light, of course dark reaction will take place. If there is no light, dark reaction will still take place. But remember, dark reaction takes place during day. Okay, so the first phase is light reaction, and this light reaction, as I already told you, that it is because of those pigments, that is a photosystem that is those chlorophylls, carotenoids, xanthophylls. So this light reaction it takes place in thylakoids, because those pigments, those pigment systems, they are present in thylakoids. So that is why this light reaction takes place in thylakoid membranes, or you can say those grana. And this light reaction occurs in presence of light, so that is why it is known as light reaction. This light reaction can be studied under following headings. The most important part of this light reaction is photophosphorylation. But in addition to the photophosphorylation, there are two other topics that we have to discuss. The first topic is red drop and Emerson's effect. Before going into red drop and Emerson's effect, here is the general overview, basic concept of energy transfer, what happens in light reaction. Okay, so as I already told you that in case of light reaction, the light, the solar energy, it is put on those pigment molecules, then it excites the electrons and so on and so on. So here what you are seeing is the antenna complex. These antenna complex are other pigment molecules. These are different chlorophyll molecules, carotenoids and phycophyllenes. So what happens here, light is put on these pigment molecules on this antenna complex, and they excite the electron, energy is released. That energy is ultimately put to the reaction center. The reaction center may be either PS1 photosystem 1 or photosystem 2. So at the reaction center, this electron, it is this donor gives the electron to this reaction center, and then this reaction center gives this electron to acceptor. So this is how energy transfer takes place, and then electron transfer takes place. We are going to talk about this in detail later on. So the light reaction, first step of light reaction is red drop and Emerson effect. Red drop, as you see, drop means decline and red means in the red region. So what happens here, so this red drop, it is defined in the form of quantum yield. Quantum yield simply means the number of oxygen molecules evolved per light quanta absorbed. You know that light has both particle as well as wave nature. Now when we say the particle nature, this particle nature of light is measured in case of quanta of light. We say photons and quanta and so on. So quantum yield means number of oxygen molecules evolved per light quanta absorbed. Ultimately, in case of photosynthesis, you know that oxygen is evolved, oxygen is released. So how many molecules of oxygen are released when one light quanta is absorbed? This is known as quantum yield. More the quantum yield, more is the rate of photosynthesis. Remember this point. More the quantum yield and more is the rate of photosynthesis. That means जितना ज़्यादा oxygen release हो रहा है, उतना ज़्यादा photosynthesis हो रही है. So let's see how this red drop is defined. It means the sharp decline of quantum yield, that means a sharp decline in rate of photosynthesis when chloroplasts are illuminated. When far red light is illuminated, when far red light is put on the chloroplasts, there is decline, there is decrease in the rate of photosynthesis, or you can say there is decrease in the quantum yield. Now, why is this decrease? We'll see later on. Now, this decrease in quantum yield takes place in red region, because what we did, we illuminated chloroplasts with far red light. That means red region में क्या हो रहा है, decline हो रहा है, photosynthesis में decline हो रहा है, quantum yield में. That is why this phenomena, it is known as red drop. Okay, so this red drop and other Emerson aspect, they were discovered by Emerson later on. Okay, so next part is here. You can see this is the spectrum. This is the spectrum. This is the type of electromagnetic radiation. This is electromagnetic radiation. It consists of gamma rays, X-rays, ultraviolet, and then visible spectrum, infrared, microwave, radio waves. So here what you are seeing, the visible spectrum. So in case of visible spectrum, in the second graph you see that absorption spectrum and quantum yield. So absorption spectrum, as I already told, that in case of two regions, you can see two peaks between 400 500 and one more peak between 600 700. There are two peaks. That means in case of blue and red region, more light is absorbed, and when there is more light absorbed, quantum yield is higher in case of these two peaks, right? In case of two regions, because that means rate of photosynthesis is higher. That is action spectrum. So you understand quantum yield. Now the next point is Emerson enhancement effect. So what happened now? Emerson found that quantum yield, this quantum yield, that means rate of photosynthesis, can be increased to full efficiency if supplementary red light of shorter wavelength is provided simultaneously. You know that red light, after before there is red light, then there is far red light. Because in case of VIBGOR, we say violet, indigo, blue, green, orange, red, yellow, red, and after red there is far red. So far red has longer wavelength and red has shorter wavelength. So what Emerson found that when these chloroplasts, when they were illuminated with far red light, quantum yield decreases, right? Now this quantum yield can be increased to its full efficiency by how? By radiating these chloroplasts with supplementary red light, which is of shorter wavelength. So this increase in quantum yield when both red and far red light, जब दोनों एक साथ दिए जा रहे हैं रेड एंड फॉर लाइट, इसी को बोला जाता है एमर्सन एनहांसमेंट इफेक्ट. द क्वांटम यील्ड इन कंबाइंड बीम, दैट इज जब हम दोनों बीम्स को कंबाइन कर रहे हैं, रेड और फॉर रेड को, क्वांटम यील्ड सबसे ज़्यादा होता है relative to what? Relative to individual beams, relative to individual or separate beams. Here this can be explained with the help of a graph here, with this help of a diagram here. So what you are seeing on the left side is far red light on. सबसे पहले हम far red light on कर रहे हैं, और आपकी जो relative rate of photosynthesis, y axis में relative rate of photosynthesis, x axis में यहाँ पे टाइम और रेड लाइट कैसी कैसी दी जा रही है. तो आप लोग देख रहे हो जब far red light ऑन की जाती है तो रेट ऑफ फोटोसिंथेसिस कम है, फिर इसी far red light को ऑफ किया जाता है, फिर अलग से रेड लाइट दी जाती है तो रेट ऑफ फोटोसिंथेसिस भी और भी कम है, फिर उसको ऑफ किया जाता है. फिर जब दोनों लाइट्स ऑन किए जाते हैं, दोनों लाइट्स को कंबाइन किया जा रहा है, आप लोग क्वांटम यील्ड का देखो कितना हाई ऊपर हो जा रहा है. So this rate of photosynthesis when red and far red light are given together is greater than the sum of rates when they are given apart. You understand the point? That is why it is known as simultaneous increase in the increase in the quantum yield or rate of photosynthesis by simultaneously giving red and far light. It is known as Emerson's enhancement effect. So this is all for today. Tomorrow we are going to talk about photosystems. Thank you.